Equipment Lesson 5 covers Automatic Exposure Control, AEC. AEC is the system that terminates your exposure automatically when the correct amount of radiation has reached the detector, so that image density stays consistent regardless of patient size, without you calculating MAS manually for every case. We cover how AEC works, the workflow from patient to termination, the deviation index, D1, and exposure index. EI, in digital imaging, system settings and common failure modes, and AEC quality control. 12 minutes. AEC does one thing: it measures the radiation reaching a detector beneath the patient, and when that accumulated dose hits a preset threshold, it terminates the exposure. The radiographer still selects KVP, the density adjustment, and which chamber or chambers to activate. AEC then selects the MAS automatically. 4 functions worth locking in. Primary function, consistent. Image density regardless of patient size or tissue composition. A thin patient and a large patient both produce a diagnostic image at the same window setting. How it works: ionization chambers beneath the patient and image receptor ionize air as radiation passes through. That charge accumulates. When the preset threshold is reached, the exposure stops. Solid-state detectors in modern digital systems work on the same principle using detector pixel data. Chamber selection: 3 chambers are standard: left, center, and right. The wrong chamber under the wrong anatomy produces wrong exposure. For chest radiography, select the 2 lateral chambers. The mediastinum is dense. If the center chamber drives your AEC on a chest, you will underexpose the lung. This workflow diagram shows the 6 steps that happen between the patient entering the field and the exposure terminating. Step 1, X-rays enter the patient. Step 2, the beam is attenuated, reduced, by the patient's tissues. The denser the anatomy, the less radiation exits. Step 3, the attenuated beam reaches the ionization chamber beneath the patient. Step 4, charge accumulates in the chamber as radiation ionizes the air. Step 5, the AEC controller continuously monitors accumulated charge, asking, has the threshold been reached? Step 6, when the threshold is met, the exposure terminates. On the lower portion of this slide are the 3 AEC chambers shown in their anatomical positions: left and right. For chest lateral coverage. Center for abdomen, spine, pelvis, and skull work. The key warning printed on that diagram is critical: for chest radiography, always use left and right, not center. The center chamber reads mediastinal density. If it drives the exposure, the lung fields will be dark, and the system will terminate prematurely for the lung tissue that actually needs the exposure. In digital imaging, the AEC doesn't just control exposure termination, it works in concert with 2 numbers that tell you whether that termination happened at the right dose level. The exposure index, EI, is a number generated by the digital detector reflecting how much radiation reached it. Higher EI means more radiation. Each manufacturer uses a different EI scale, but the deviation index, D1, is standardized across manufacturers. Look at the D1 scale bar on this slide. It runs from severely underexposed on the left through optimal at 0 to severely overexposed on the right. D1 equals 0, optimal. Perfect. D1 greater than +1, overexposed, more than 25% above target. D1 less than -1, underexposed, more than 25% below target. D1 beyond plus or minus 3, significant deviation. Requiring investigation and technique correction. The critical concept for digital imaging practice, a visually acceptable image does not mean the exposure was appropriate. Digital detectors compensate electronically for overexposure. An image that looks perfect on screen may have a D1 of +2 or +3, meaning the patient received 2 to 4 times the necessary dose. Monitor the D1 on every single exposure. For settings govern AEC performance. Minimum response time, the shortest exposure the AEC can accurately terminate. Modern systems, typically 1 to 5 milliseconds. If the required exposure is shorter than the minimum response time, the AEC cannot respond fast enough, and the exposure overruns. This is the primary danger for very small or thin patients, especially pediatric cases. Solution: reduce the MA station, which lengthens the required exposure time into the AEC's response range. Backup timer, an independent safety timer that terminates the exposure if the AEC fails to do so. Must be set to 150% or less of the expected maximum MAS. If the backup timer fires, that is a malfunction, not normal operation. Take the unit out of service immediately. Density control plus or minus adjusts the radiation threshold in approximately 25 to 30% increments per step. Use this when images are consistently too light or too dark. Despite correct chamber selection and centering, it is not a substitute for correct positioning. Centering and field size, the patient must be centered over. This bar chart shows a key AEC QC concept, MAS variation, across different KVP settings. In a properly calibrated system, the AEC should produce consistent image density. Across a range of KVP values, the bars stay close to zero. Deviation. Large variation across KVP stations indicates AEC calibration drift. 5 AEC QC tests. Reproducibility, MAS variation within plus or minus 5% across repeated exposures at identical settings. KVP consistency, consistent image density. As KVP changes across the operating range. Chamber alignment. Chambers verified under correct anatomy positions for each exam type. Minimum response time check, thin phantom exposure. Confirms no overexposure from response time lag. And backup. Timer function, AEC deliberately bypassed, backup timer. Must terminate correctly at the set threshold. 3 AEC questions. These are the scenarios the registry tests. Think before the answer appears. The answer is B. Adjust the AEC density selector to a lower, negative setting. If the image is consistently too dark, overexposed, with correct chamber selection and centering, the AEC threshold is set too high, it's requiring more radiation than needed before terminating. Reducing the density selector to a negative value decreases the threshold, causing the AEC to terminate earlier and produce a properly exposed image. The answer is C. The required exposure was shorter than the AEC minimum response time. Small pediatric patients require very little radiation for adequate exposure. If that required time is shorter than the AEC's minimum response time, typically 1 to 5 milliseconds, the AEC cannot respond fast enough, and the exposure overshoots. The solution is to reduce the MA station, lengthening the Required exposure time into the AEC's operating range. The answer is B. The shield was placed over the AEC chamber, and the AEC overexposed the patient trying to compensate. When the gonadal shield covers the ionization chamber, the chamber receives essentially no radiation. The AEC continues running, trying to reach its preset threshold, and dramatically overexposes. For AEC-controlled pelvic exams, shielding must be outside the chamber area, or manual technique must be used. You covered AEC function and chamber selection, the 6-step workflow diagram, the deviation index scale with what each zone means, system settings including minimum response time and backup timer failure modes, and AEC quality control testing. AEC is only as accurate as the centering, chamber selection, and technique settings that feed into it.